Imagine cruising down the highway at 70 miles per hour. Your car is doing all the driving, you're relaxed, and then suddenly a sensor fails. Welcome to The Explainer. I am so incredibly excited you're joining us today because we are diving into a massive, almost invisible technological shift that's happening right now in vehicle safety. It's a shift that is completely changing the relationship between you and the car you drive. Look, we all know we're moving toward this sci-fi future of intelligent autonomous driving, right? But to get there safely, the automotive industry is quietly dumping billions of dollars into something called driver override systems. So today, we are going to break down exactly what this tech is, why the market is literally exploding, and what it all means for your daily commute. Okay, let's dive right into this, because the numbers here are simply staggering. We are talking about a market that's projected to be valued at $5.18 billion by 2026. But wait, it doesn't stop there. It is estimated to reach a massive $12.74 billion by 2034. That is a compound annual growth rate of 11.9%, almost 12% growth every single year. That kind of rapid, sustained explosion tells us one huge thing. Automakers aren't just experimenting anymore. They are in a desperate race to integrate this technology. So you're probably wondering, what exactly is fueling this multi-billion-dollar boom? Well, before we get into the market forces, let's be absolutely clear on what a driver override system actually is. At their core, these are human-machine intervention frameworks. Now, in plain English, as cars take on more of the driving responsibilities, things like steering, braking, lane keeping, there has to be a foolproof, split-second mechanism that allows you, the human being, to take back control the exact moment things get tricky. Or vice versa. It's that invisible, completely seamless switch between the car's AI algorithms and your own manual control. Simply put, it is the ultimate failsafe. Section 1. Forces driving the growth. Let's take a look at the macro-level shifts that are practically forcing the whole auto industry to adapt and spend billions in the process. There are really three primary engines powering this expansion. First up, the rapid commercialization of autonomous and semi-autonomous vehicles. As fleets of robotaxis and intelligent freight trucks actually hit our roads, having safe human intervention mechanisms becomes completely non-negotiable. Second, stricter global safety mandates. Governments and regulators all over the world are laying down the law, absolutely mandating these failsafes to minimize the risk of accidents from, say, a sensor failure or a random software bug. And third, the sheer unpredictability of urban traffic. AI algorithms are brilliant, for sure, but mixed traffic city environments are chaotic. A pedestrian stepping unexpectedly off a curb, that requires an intelligent fallback system that hands control back to you instantly, without a fatal delay. All right, Section 2, the technology under the hood. We're going to zoom in and see exactly what kind of tech is dominating today versus where it's heading tomorrow. Now, what's really fascinating here is the massive chunk of the market currently held by electronic override control systems, sitting right at 42.8%. So why do they dominate today? It really just comes down to integration. These highly accurate, real-time systems integrate perfectly with the electronic architectures of modern cars. As our vehicles rely more and more on centralized electronic frameworks to boost efficiency and precision, these electronic override systems naturally fit right in to act as that critical intervention tool. And guess where those electronic systems are heavily targeted? Right at your everyday commute. Passenger cars hold the largest share of the market right now, at 46.3%. This is a crucial takeaway for us. Driver override systems are no longer just fancy luxury add-ons for high-end sports cars. Automakers are making these systems a standard safety requirement across mid-range categories too, driven heavily by consumer awareness and the constant push for high safety ratings. Commercial vehicles, though, are anticipated to record the fastest growth, mostly because fleet operators are desperately looking to reduce driver fatigue and operational risks. Looking a bit deeper into the tech segment, nearly half the market relies on ADAS-integrated override systems. These act as the bridge, ensuring smooth coordination between automated features and your manual inputs. It's basically the bread and butter of today's safety frameworks. But keep an eye on that AI-based slice. Artificial intelligence is projected to witness the absolute fastest growth, moving us away from purely reactive systems toward predictive safety mechanisms that continuously learn from real-time data. It's going to be huge. And this builds directly into the future of automotive engineering. The crucial pivot happening right now is this shift from present tech to future tech. Today, we're very hardware reliant, but tomorrow belongs to the software-defined vehicle ecosystem. Think about how you update your smartphone over the air while you sleep, right? Cars are moving to this exact same model. Driver override systems will increasingly be software-based modules, meaning manufacturers can remotely deploy improvements, enhance responsiveness, and introduce brand new safety features without ever touching a physical component in the car. Paired with AI that anticipates hazards before they even happen, that is the ultimate game changer for scalable safety. To truly appreciate this, let's walk through how these systems process a split-second emergency using redundant multi-layer architectures. Step 1. The system is continuously crunching massive amounts of sensor data. Step 2. The AI predicts potential hazards before a human ever realistically could. Step 3 is where the magic of redundancy comes in. Dynamic control shifts via multiple independent pathways for steering and braking. Basically, if one pathway fails, another instantly takes over. No questions asked, which ensures Step 4. Seamless, uninterrupted human intervention. No fatal delays, just a flawless, invisible handover of control back to you. Section 3. Speed bumps and market roadblocks. Because let's be real, it sounds like an autonomous utopia, but it's definitely not completely smooth sailing just yet. The roadblocks really come down to three massive hurdles: high system complexity, massive development costs, and strict real-time interoperability demands. Think about what we literally just discussed: coordinating multiple electronic control units, countless sensors, and heavy layers of software seamlessly in real time. It is unbelievably technically demanding. For mid-tier automakers especially, ensuring that real-time responsiveness without any lag requires high-performance computing that significantly spikes their production costs and development timelines. Plus, just getting different vehicle platforms and software ecosystems to talk to each other flawlessly, that is creating some major implementation bottlenecks across the industry. Section 4. The global automotive race. Because despite those speed bumps, the demand is just way too high to stop the momentum now. Zooming out to look at the global landscape, North America is currently dominating the track with a 38.6% market share for 2025. This is mostly driven by early adoption of autonomous tech and really strong regulatory support for testing in the US. Europe holds about 27.4%, heavily supported by strict safety rules and, of course, Germany's unmatched luxury engineering, where high-end safety features are always prioritized. But you absolutely have to keep your eyes on the Asia-Pacific region. It's the fastest-growing market out there, with a 13.4% compound annual growth rate. This is fueled heavily by China's massive smart city initiatives, their 5G connectivity infrastructure, and explosive electric vehicle growth. They are literally building the digital roads of the future specifically for these connected systems. So, who's actually building all this incredible technology? Well, the market is moderately competitive, led by Tier 1 automotive giants like Continental, Denso, ZF, and Aptiv. They are battling it out, investing heavily in software-driven safety solutions. But Robert Bosch GmbH is a particularly notable leader right now. They maintain a massive global presence and have recently made aggressive, continuous pushes into developing AI-based, real-time driver intervention capabilities. They are actively trying to own that critical, split-second moment when a vehicle hands control back to a human being. And honestly, that brings us to the most fascinating aspect of this entire $12 billion boom. All of this investment, all of this redundant architecture, all this artificial intelligence, it's all designed for one single terrifying moment in time. So I'm going to leave you with this final provocative thought. In a split-second traffic emergency, who do you trust more to take the wheel, yourself or the AI? It is a question that automotive engineers are spending billions to answer seamlessly. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time as we decode the next big technological shift.